All right, let's get started. Welcome, good morning. I'm Edward Name. I'm the GM of Amazon FSx, and I'm joined by Prashant Bungale, who's a Senior Product Manager for FSx, and Daryl Osborne, who's Senior Solutions Architect for FSx. We're really excited to be here on this last day of reInvent, talking to you today about Amazon FSx for Windows File Server. It's a new service that we launched on Wednesday. Andy Jassy announced it during his keynote. We launched it at that point. And so we're eager to tell you the details about it. So in this session, we'll start with a very brief overview of AWS's storage portfolio. And then we'll talk quickly about running Windows applications on AWS. We'll then spend a good amount of time getting into the details of FSx. So what it is, why we built it, and how it can benefit you, and how you can use it. And then Daryl's going to spend some time going through FSx in action. And so he'll talk about a few different reference deployments, so how to configure FSx in your environment to do various, to achieve various things. And he'll do some hands-on demos as well, showing you basic setup and showing you some performance results using FSx. And then we'll save time at the end for Q&A. So let's start with an overview of AWS's storage offerings. And the summary is that we have a rich set of storage offerings to support whatever workloads you want to run on AWS. We have object and archival storage, so that's S3 and S3 Glacier. We have locally attached storage, so EC2 local storage and EBS, and those are, you can think of them as volumes or disks that are attached to a single instance. And it's been an exciting week for our file offerings. We, of course, announced FSx for Windows File Server. We also announced another FSx offering, FSx for Lustre, which is for machine learning, HPC, media and entertainment workflows, so really compute-intensive workloads. And we also announced that coming soon is EFS IA, which is an infrequent access, lower-priced class for our EFS offering. And then we have a wide set of data movement services. That's for moving data into and out of AWS and between services. And when we refer to file storage, we're really talking about network file storage. And why is network file storage so useful? Well, first, files and directories appear and work just like they would on local storage, but you have the access of that data being available across the network. So multiple users, computers, and applications have access to the same set of files, and they can access them concurrently. And it provides strong consistency, even if multiple users or applications are touching the same file concurrently. Network file storage also generally provides high levels of throughput in IOPS, and that's really because if you have a number of users or applications or servers accessing the same set of data, you need to provide high levels of throughput and high levels of IOPS so they can do all of that concurrently. And most network file storage really provides near local latencies, because latencies are very important for a lot of applications. And then another key part of network file storage is its file storage. And so it appears like and works like a local file system would on your computer or on your server. So existing applications, existing IT environments don't require changes. The operating system APIs for working with files just work with it. And now most of you are here because you're running or are looking to run Windows on AWS. And we have lots and lots of customers that are running their mission-critical Windows applications on AWS. In fact, almost 2/3 of Windows instances running on the public cloud are running on AWS. And really, that's because of the combination of the experience we have at AWS, over 10 years of running Windows on AWS, the rich services we provide for running Windows, and the compelling TCO across our different Windows offerings. And a big part of running Windows applications is operating the file storage for those applications. And probably something that most folks in this room can relate to is that managing Windows file servers on-prem is a pretty big challenge. And there's really kind of two big things that you need to worry about and think about when you're managing your Windows file servers. So the first is managing the hardware. So everything from planning capacity to procuring and purchasing the hardware, often with long lead times, setting up storage servers and volumes, detecting and addressing hardware failures, and making CapEx investments. And then there's the software part. So installing and configuring server software, setting up and configuring the file system and the file serving software, applying Windows updates, managing software licenses, managing backups, managing security, managing monitoring, all of those things. And that, it gets significantly easier if you're running those Windows file servers on the cloud. And that's because the headaches tied to managing the hardware are gone. So you can easily spin up and spin down EC2 and EBS volumes. You don't need to manage the underlying hardware, but you still need to manage the software. And so customers have been telling us that they don't want to manage the hardware or the software. And that's what we set off to solve for customers with FSx. And so our overarching goal for FSx for Windows File Server was to deliver the best solution for the lift and shift of your Windows storage to the cloud. And that really meant three things. The first is 100% Windows application compatibility. Windows applications are written for and they're tested against NTFS file systems with all of the unique semantics and idiosyncrasies that file system provides. And you want 100% compatibility with it. So you don't want to be figuring out why your application isn't working in strange ways or in edge cases. You just want it to work, and you want it to work with a native Windows file system. Two, lots of Windows applications work with small files. So they work with small files, and they work with a lot of metadata. And what that generally means is that they're pretty latency sensitive. Because if you're doing a lot of operations with a lot of small files, especially if you're doing them kind of in serial, the latencies of the overhead of opening each of these files or working with each of these files adds up. And you notice significant performance implications if the latency isn't really where it needs to be for the underlying file storage layer. So for us, sub-millisecond latencies were super important for this offering. At the same time, high throughput and high IOPS, also really important. That's just table stakes for any type of network file storage. And then we wanted to provide customers with flexibility based on workload needs. So what that specifically means is the ability to tune the throughput level independent of storage. So you can really kind of right-size your throughput for your workload. And then we wanted it to be enterprise ready. And what that really means is highly available, highly durable, secure, and meets compliances. And why do those things matter? Why do those three things matter? Well, the native compatibility and the strong performance means that it will just work. Your applications, you'll be able to lift and shift because you'll be able to lift and shift your file storage, and things will just work. And the security, the compliances, the availability, the durability means that you can use it for a broad spectrum of applications with sensitive data, with different enterprise requirements, et cetera. So really, we wanted this to be a robust offering as well from that perspective. And so when we first set out to meet these goals, we looked at just implementing the SMB protocol on a non-native Windows file system. And a lot of vendors, a lot of providers do that. And we realized that that just wouldn't deliver the right experience for customers. And that's because the file system matters. And you can't just tack the SMB protocol onto any file system. So for real Windows file system compatibility, you really want to have a file system that's built from the ground up to work with Windows. And it's not just the native compatibility, it's the performance as well. A file system that's really optimized for Windows types of workloads. And so the other thing that we looked at was, okay, we could actually build a Windows file system from the ground up. So really something that's completely optimized to be a Windows file system. And we took a long, hard look at doing that as well. And we realized customers, they really just want to run Windows file servers in the cloud, but not have to manage them. They don't want to deal with the muck of managing them. And we realized that that's where we could really provide the most value, was fully managing them for them. And so we went back to the drawing board, and we thought about how we could do this. And we saw a lot of parallels with Amazon RDS, which is our fully managed relational database service. And RDS, for those who aren't familiar, makes it easy to set up and operate popular relational databases like MySQL, Postgres, MariaDB, SQL Server. And so that's exactly the approach we ended up taking with Amazon FSx for Windows File Server. And what we decided to deliver were Windows file systems built on fully managed Windows servers and integrated richly with other AWS services. And we're calling that Amazon FSx for Windows File Server. And we're confident that this is the best solution out there for lifting and shifting your Windows file storage to the cloud. And let's talk specifically about what the service provides. I'm going to hand it over to Prash to walk us through that.
Thanks, Ed. So remember the 3 design goals that Ed talked about earlier? Let's talk about how the FSx benefits actually meet these goals. So by being built on Windows Server, as we mentioned, you get the native Windows file storage that is able to deliver the compatibility, the feature set, and the native performance that's needed for your Windows applications. So when we say we provide NTFS file systems, it basically comes with all of the NTFS file system features, including what a lot of your applications might either explicitly or implicitly be relying on. Whether it's things like extended attributes, things like file change notifications, alternate data streams, hard links, soft links. There's a wide variety of feature set lying underneath the file system. And then we fully support SMB protocol, all the current versions of the SMB protocol, everywhere from 2.0 to 3.1.1, which is the latest version. When we say we fully support SMB, it includes all of the SMB features for things like SMB multi-channel, where you can use a single client establishing multiple TCP connections against the file server in order to drive higher throughput and IOPS. It also includes SMB features like directory leasing and file leasing to help your clients be able to cache the file data locally so that their applications can get the optimal performance. And we actually integrate with Active Directory in order to allow you to integrate with your existing IT environments seamlessly. So the way you would do this is you would join your file system to a Microsoft Active Directory that's managed by AWS. And if you want to be able to use your own self-managed Active Directory, you can actually link the self-managed Active Directory with the AWS managed Active Directory using one-way forest trust relationships, where it basically means that you are asking the AWS managed AD to trust the identities that are authenticated and provided by your self-managed Active Directory, whether it's on-prem or in AWS, for that matter. So by integrating with Active Directory, what we are able to support is basically the use of access control lists in NTFS file systems in order to allow you to control access to individual files and directories from users and groups in your Active Directory. And then we also support a lot of the other Windows features, including not just file system features, but also sort of ecosystem features for things like distributed file system, where you can actually use the DFS namespaces feature to group lots of file servers together, to consolidate your file servers into one common namespace so that your applications can access your files and directories through this common namespace without having to worry about which file server is hosting which file data. You can also use DFS replication to replicate your data across multiple availability zones in order to get higher availability and durability. You can also use DFS replication to scale out your performance and so on and so forth. There's a rich set of capabilities you can actually get by using this DFS support. Let's talk about the second aspect, which is fast and flexible performance. By being built on high-performance SSD storage, we are actually able to provide consistent sub-millisecond latencies. And Ed already talked about why this is really important, because your applications, in the best case, might actually be impacted in terms of performance, and in the worst case, they might even break in unexpected ways. So this was really important for us, and we are able to deliver the consistent sub-millisecond latencies. We also provide high throughput and IOPS. You can actually drive up to 2 gigabytes per second of throughput per file system. and up to hundreds of thousands of IOPS per file system. And you can even scale out this performance across lots of file systems in order to get tens of gigabytes per second of throughput and hundreds of thousands to millions of IOPS per namespace when you're using DFS namespaces to group multiple file systems. By flexible, we also mean that you can choose the throughput level independent of the storage level. And here, what it allows you to do is to basically cater to different price-performance ratios that your applications need. There's a wide variety of use cases out there that need lots of different kinds of performance to storage ratios. We also can talk about the performance model here a little bit more. So every Amazon FSx for Windows File Server file system provides something called a throughput capacity, which is the speed at which your file server that's hosting the file system underneath can serve the file data. You configure this throughput capacity when you create a file system. The throughput capacity itself can range from 8 megabytes per second all the way to 2 gigabytes per second. Now, what this represents is the sustained, meaning the 24/7 throughput that you can drive on your file system. What we observed was file-based workloads generally tend to be very spiky in nature, meaning that there tends to be highly intense periods of very high I/O activity, and then plenty of time in between where your file system tends to be idle. So to support these kinds of spiky workload needs, what we do is we allow you to burst to much higher levels of throughput at each of these throughput capacity levels, or for the smaller throughput capacity levels. What this allows you to do is burst for at least 30 minutes a day to these much higher speeds. For example, even with the 8 megabytes per second sustained, you actually can burst up to 200 megabytes per second for at least 30 minutes a day. And depending on how much throughput you're driving, between 8 and 200, you can actually drive even longer periods of burst per day. And then, even further, the file server that we manage for you, we actually support in-memory caching on that file server. So what that means is your applications can actually benefit from file server caching depending on the workload characteristics and access patterns. And by benefiting from the in-memory caching that the file server provides, you can actually drive even higher levels of throughput, anywhere between 600 megabytes per second and 3 gigabytes per second. The third aspect that we talked about was this set of features that makes the service enterprise ready. So let's talk about the first subset of that, which is high availability and high durability. So the service continually monitors your underlying file serving infrastructure, and it addresses any hardware failures as and when they occur. It replicates data within an availability zone, and it stores backups in a highly durable way in Amazon S3. So we allow you to take a backup of a file system as a point-in-time snapshot of your file system. So what that means is the backup is file system consistent. We provide two different ways of doing backup. We automatically provide you a daily backup. By default, for every file system that's created, we give you the daily backups automatically. And we allow you to even enforce a retention policy on that. For example, 7 days, 30 days, and so on. And then, in addition to that, we allow you to take backups yourself at any point in time. And we also give you a solution separately to schedule your backups on a custom basis. Say you need more frequently than once a day, or you need less frequently. And you need different kinds of retention policies to support your compliance needs, whether it's 1 year retention, 7 years retention, whatever it be. So there's a lot of support that we provide you for backing up your file systems. And then one other thing I'll note about backups is the backup storage itself is incremental, meaning that only the changes that you've made since the last backup would actually occupy additional backup storage. So that helps you save on costs for the backup storage. We support multi-AZ deployments of file systems as well, where you can use DFS namespaces and DFS replication to achieve the multi-AZ redundancy. The second subset of enterprise readiness I'll talk about is the security and compliance features. The first thing I'll talk about is encryption. All data in Amazon FSx is always encrypted. You don't need to do anything to enable it as such. The data itself is encrypted using keys that you manage in AWS Key Management Service, or KMS. And you can use either AWS managed CMKs or customer managed CMKs. So we support both. Data is also encrypted in transit using SMB Kerberos session keys because of the integration with Active Directory. We integrate with the AWS managed Microsoft Active Directory, as I already mentioned, as well as your corporate Active Directory, whether it's on-prem or in AWS via trust relationships. And by doing this, we can actually support access control at the individual file and folder level, which is paramount for a lot of enterprises. And then we also allow you to control access to network traffic using Amazon VPC and VPC security groups. Every file system is basically presented as a network interface in your VPC, and then you can actually control who has access and doesn't have access to that network endpoint. And then you can also control who has access to the API within the service, meaning that you can control who can do administrative activities like creating file systems, deleting file systems, taking backups, and so on. And this you can do using the integration that we provide with Identity and Access Management Service, or IAM. You can also monitor and log API calls using the integration that we provide with AWS CloudTrail. And finally, we provide a lot of compliance support from the get-go, from day one. We support PCI DSS, we support ISO, and we are also HIPAA eligible. So two other aspects that I'd like to highlight, in addition to the three sort of design goals that we talked about already, are broad accessibility and fully managed aspects. So enterprise IT environments typically have a mix of applications and workloads that run on a wide variety of compute instances and that require a wide variety of operating system client access. The thing about this is they need access to the same data set, the same file data set at the same time. So really, to provide support for these kinds of enterprise IT environments, we need to support a broad variety of compute instance types and operating systems. And we recognize that this is critical. So we actually support access from Amazon EC2 instances, from VMware Cloud on AWS VMs, from Amazon Workspaces instances, as well as from Amazon AppStream 2.0 instances. And then we also support a wide variety of operating systems. When it comes to Windows Server versions, we support everything starting from 2008 all the way to the latest version. When it comes to desktop versions, we support everything starting from Windows 7. And then we also support access from Linux clients using the Samba client, the open source Samba tool. And really, we are able to provide this because we are supporting all current versions of SMB and because we are providing this Windows native support. The last one I'll talk about is fully managed. So the service itself takes care of provisioning and setting up your file servers and your storage volumes. It takes care of updating your Windows software on a regular basis. It also takes care of automatically taking backups for you and managing these backups in terms of retention policies and so on your behalf. So really, you don't have to deal with the muck of managing the file serving infrastructure itself, and you can focus on your applications. So at this point, I'd like to ask Ed to talk about the use cases.
All right. Thanks, Prash. So we've designed FSx to support a wide spectrum of use cases because that's the feedback that we got from customers, that there's just so many Windows workloads that you want to run on AWS. So of course, there's kind of the traditional home directories, line of business applications, web serving and content management, software development environments, but also things like media workflows. There's a lot of video processing and transcoding applications that are written on Windows, and they need to drive high levels of throughput and are very latency sensitive. Similarly, analytics and some big data analytics workloads. So really, our goal is broad spectrum of use case support. And we've actually had some customers testing early versions of FSx. And honestly, nothing is as satisfying as hearing customers talk about your product as meeting the goals you set out for it. And so in the words, for example, of Mark Gogol from T. Rowe Price, FSx is a game changer because no other cloud solution offers the full Windows compatibility and performance that FSx does. This is based on their testing. And Greg Bell from Infor shared with us that by offloading the full management of Windows file storage, FSx will allow Infor to spend more time focusing on their core business. And that's really our goal. So let's talk about pricing. So there are 3 dimensions to think about with pricing. The first is storage capacity. The second is throughput capacity, and that's the throughput level that Prash had mentioned earlier. And then the third is backup pricing. So storage capacity is 13 cents per gigabyte per month. Throughput capacity is $2.20 per megabyte per second per month. And then backup pricing is 5 cents per gigabyte per month. And let me walk through an example just to kind of make this crisp. So let's say that you have a file system that has a terabyte of storage, and you provision 8 megabytes per second of baseline throughput. And that's more than enough for most 1 terabyte file systems, especially because you get burst capabilities as well. So with this setup, for the 1,024 gigabytes, or 1 terabyte, that's 13 cents times 1024, so that's $133 a month for the storage. For the 8 megabytes per second times 220 per megabyte per second, you get $18 a month. And that gives you a total of $151. And that works out to just under 15 cents per gigabyte per month, so 14.7 cents per gigabyte per month. And now if you add on backups as well, for people who want to take backups, 500, let's say you have 500 gigabytes worth of backups for this 1 terabyte file system. At 5 cents a month, that's another $25. And so all in, you're looking at a total of $176, or 17.2 cents per gigabyte per month. That's the full cost, including the cost of the backups. And when we announced the service on Wednesday, it was immediately available in 4 regions: US West Oregon, US East Northern Virginia, US East Ohio, and EU Ireland. And we will be launching the service in many other regions pretty quickly. And I'll just take a step back for a second and talk about FSx as a whole. On Wednesday, we announced the Amazon FSx Family. And what FSx provides as a service is fully managed third-party file systems. And these are file systems that are optimized for different workloads or for different environments. And there's 4 key tenets to FSx. The first is simple and fully managed. So no need for you to manage file servers, storage, and the software for these third-party file systems. The second is providing you the third-party file systems. And what that really means is the native compatibility, the feature set, and the performance of these third-party file systems. A lot of these file systems have been evolving over 20, 30 years and giving you the ability to really take advantage of them, run them on AWS. Third, providing rich integrations between those file systems and AWS. And in many ways, those integrations allow you to get even more value out of running the file systems than if you were doing them just on your own. And then the final is cost optimized, so really optimized for particular workloads. The other one that we announced, the other file system that we announced as part of FSx on Wednesday and that we launched is FSx for Lustre. And Lustre is an open source parallel file system that allows you to drive hundreds of gigabytes per second of throughput, millions of IOPS, and sub-millisecond latencies. And it's heavily used within the high-performance computing space, machine learning. There's a number of media and entertainment workflows that people run on Lustre. And the FSx for Lustre service, it integrates directly with S3. And so kind of the way that it works is you launch this Lustre file system, you tie it to your S3 bucket. FSx automatically moves data in from the S3 bucket onto the file system when particular files are accessed from your application. So we call that lazy loading. And we provide a commit function that allows you to write incremental changes back to S3, back to your S3 bucket. And so kind of the flow is, I have my data on an S3 data lake, I want to process it, I spin up this file system that's linked to the bucket, I crunch through the data, I write results back, and I tear down the file system. And so that's an example of when we talk about AWS integrations and really allowing you to get even more value out of these third-party file systems. The integration with S3, I think, is going to be hopefully pretty valuable for folks. And it's also cost optimized for kind of these ephemeral type workloads. So you can find more details about that online. Okay, and I'll now turn it over to Daryl, who's going to dive into how to deploy FSx and do some interesting demos.
Thanks, Ed. Well, good morning. What a great week. This has been amazing. By a show of hands, for how many of you is this your first reInvent? Wow, look at that. How about second? Good. Third? All right, let's go all the way to 4, 5, 6. Look at that. Amazing. Thank you so much. Thank you so much for your dedication, for coming to reInvent year after year to experience the things that we want to share with you each year. It's been a great week for us, specifically around file storage, with the announcements that we made with Amazon FSx for Windows File Server and Amazon FSx for Lustre, as well as the pre-announcement of Amazon EFS IA infrequent access. I have the opportunity as a solutions architect to work with a lot of you on your file storage needs. So I work with Amazon EFS and now Amazon FSx. So we're really excited to share with you some of our best practices. And I can work with you individually as organizations and developers to help you optimize your workloads, your applications on our platform. Really the best way to share with you how we have made running Windows file servers on AWS to give you high performance, to make sure that it's 100% Windows compatible, so that if you have Windows applications that need file storage needs on-prem, that you can go ahead and lift and shift those over to the cloud. And again, we wanted to make this enterprise-ready day one. So really the best way to share that is to show you. So I'm going to go ahead and share with you just how easy it is to create a new file system. So here we are in the FSx console. Click on Create File System. Again, now we have our two options, Amazon FSx for Windows File Server or Amazon FSx for Lustre. Of course, we're going to select Windows File Server. Scroll down, click on Next. Here we have the option to go ahead and put in a name. This is a description. We're not going to use this name to access the file system. This is more of a key value pair, okay? So I'm going to go ahead and call it File System. I think I'm at D. Now, when I tab off, I have the opportunity to put in the storage capacity. So I'm going to go ahead and give it, I'll make it 4 terabytes, okay? When I tab off of that, we do have a recommended throughput based on the size of your file system and the information that we have gathered. We typically think that a 4 terabyte file system, you would need around 64 megabytes per second. So that's our recommendation. But if your workload requires more throughput, you can go ahead and select another value. So I'm going to go ahead and specify, say, 128 megabytes per second. As we scroll through here, we see that we do give you an estimated monthly cost, which is nice. So based on the 3 dimensions that Ed talked about in terms of storage capacity, throughput capacity, and the amount of data that you're storing in your backups, we give you that information here. So we give you how much it's going to cost you for storage and for throughput. As we scroll down, we have the opportunity to now select where we're going to host this file server. So I have a VPC already set up. I can select what availability zone. And then within that availability zone, I can select the subnet. We expose your file system in your VPC as an ENI, an elastic network interface. As all ENIs within your VPC, you control network access to your file system using security groups associated with this ENI. So in this example, I have one security group associated with my file system using my ENI. If I wanted to add more security groups, up to 5, I can go ahead and do that here, or I can do that through the EC2 console around the ENI, the specific ENI for my file system. I'm going to go ahead and select an Active Directory, an AWS Managed Microsoft Active Directory that I already have set up. Then I'll select the AWS KMS key that will be used to manage the keys to encrypt your data at rest. Again, you can select an AWS Managed CMK or a Customer Managed CMK. I'll go ahead and select the default. And now we have the maintenance preferences. So as Ed mentioned, we have daily automatic backups of your file system. So here you can identify a 30-minute window each day that we will take a file system consistent incremental backup of your file system. I don't have a preference, so I'm just going to leave it at no preference right now. You also have the opportunity to select the retention period for these automatic backups. Anywhere from 0 means that you're not going to have an automatic daily backup, all the way up to 35 days. If you need a backup that goes beyond 35 days, you can also initiate a user-initiated backup at any time, and you manage the retention of the user-initiated backups. We also have the weekly maintenance window. So again, you would identify a day, an hour, and a minute where a 30-minute window will start, where if we need to do maintenance on your file server, we would do it in that weekly maintenance window. You would be notified, and this isn't something we're going to do each week. You know, when there is a need that arises, we would go ahead and do maintenance that week. It's not going to be down for the entire 30 minutes. It could be down for a few seconds, maybe a minute or so. You can, if your application can't sustain an outage of, say, a minute when we're doing maintenance on your file system, you can set up DFS namespaces and DFS replication. Just make sure the two file systems don't have the same maintenance window. And then your applications will be able to access the files on the other file system. I don't have any preferences for my maintenance windows, so I'll go ahead and select Next. Here we can just review all of the settings and click Create File System. So it really is that simple to create a file system through the UI. Even simpler if you create it through the CLI or the SDKs. So let's walk through a typical architecture of what I just did. Okay, so we start out with a region. So again, we're available in 4 regions today. Within that region, you have a VPC. Within that VPC, you're going to have multiple availability zones. In this case, we're just going to show one. Within that AZ, you have subnets. All right, so you have your Windows instances, your clients that are going to be accessing this file system. When you create that file system, again, we expose it as an ENI. And this is sort of the mechanism that you use to gain access to the file system. You actually map the file share using the DNS name of the file system. So very simple, very easy to go ahead and map that file share. You could have other subnets and clients in other subnets. Again, you can gain access to that file system in different availability zones and different subnets within your VPC. Say that you want a multi-AZ architecture. You want to have file systems in 2 AZs. Definitely you can do that. Spin up another file system in a different AZ. That's going to be also in a different subnet. You can set up DFS replication. So DFS replication will replicate asynchronously the data between the 2 file systems. Then you can configure your clients to, when data is written from one file system to another, you can configure your clients so that actually they're going to be accessing the file data in the same AZ as the file system. So you don't have inter-AZ data transfer costs. So going forward, I'm not going to be showing the ENIs, but rest assured the ENIs are there. It's just a little easier within our diagrams. So going forward, we're not going to see the ENIs. So organizing large amounts of data, you may have, so a file system can be, the storage capacity can be anywhere from 300 gigabytes to 64 terabytes. But what happens if you have more than 64 terabytes? Absolutely, you can use Amazon FSx for Windows and have multiple file systems consolidated under a single DFS namespace. So let's go ahead and take a look at what that looks like. This namespace, you could have multiple file shares, and all of those file shares would be accessible using that namespace. So that architecture, again, we're going to start out with the region, a VPC, and the availability zones and the subnets. You are going to host a namespace server in 2 different AZs. We recommend that for high availability for your namespace. You would create that namespace. You would create shares or folders under that namespace. Your clients would be able to access this namespace using its name. And then you can have multiple file systems or multiple file shares underneath that single namespace. So this is how you can actually have, with 64 terabytes per file system, you could have multiple file systems under a single namespace. This allows you to have up to 50,000 file shares under a single namespace, which allows you to grow up to, say, 3 exabytes of data under a single namespace. So really a great way to consolidate all of your file data into a single namespace so it's easy for your users and applications to get access to it. So you may be familiar with a term, read replicas, sort of from the database world as well. And this is really a way that you can scale out your read-heavy workloads like HPC data analytics, video transcoding, machine learning, AI, across multiple file systems to achieve higher and higher read performance. So what this looks like is you would have a file system, and you would have then multiple file shares that individual clients would be able to access to. And this data is replicated to those other file systems. Allows you to have different clients hitting different file systems and achieving high levels of aggregate throughput across this environment. So let's go ahead and take a look at what this looks like. Again, a region VPC and our AZs and our subnets. You would have clients in any subnet within your VPC. You would have, say, set up one file system, and that's the file system you're going to write your data to. So configure your applications to write to this one file system. You create 2 other file systems and go ahead and set up DFS replication. So if all of your clients are hitting one file system when they're writing, that's going to be distributed across all 3 file systems. Then you configure your application to actually read from the different file systems. So a group of clients hitting one file system, another group hitting another file system. This allows you to really scale out. And in this example, you can actually get 3 times the read performance because groups of clients are hitting different file servers. So you also may be familiar with the term sharding. So when you shard data, you basically separate data into your larger data set into smaller data sets. Well, you can also do that within Amazon FSx for Windows File Server. So by dividing this, you can actually achieve higher levels of throughput because you can spread that again across multiple file systems and have this all under a single namespace. And if you divide, in this example, if you divide your data alphabetically, A through F is going to hit one file system, G through M, another file system, and N through Z, a third file system, you're able to achieve high levels of throughput across all 3 file systems. So again, in this example, you can achieve high levels of throughput. If we look at how it's designed, again, because we are using DFS namespaces, we recommend that you deploy a namespace in 2 different availability zones. Create that namespace and all the folders or subdirectories underneath. Each of those are going to be pointing to a separate file system. In this example, then, we're able to really achieve 3 times the read-write performance because we're basically spreading that across multiple file systems. For backups, during the weekly backup or the daily backup time, we will go ahead and make a backup of your file system. Again, these are file system consistent incremental backups. You can keep up to 35 days for the automatic backups. If you need to keep backups longer, you can go ahead and do a user-initiated backup, and then you would maintain the retention of those backups as well. All of those backups are stored in Amazon S3. So when you create a file system, you set the storage capacity and the throughput capacity. So, we expect that most applications will be able to benefit from file caching, as Prash mentioned, really on the Windows file server that is running your file system. This is really to help you achieve higher levels of performance, higher than what you set as the throughput capacity of your file system. So you can achieve higher levels of throughput, IOPS, and still have low latencies. Prash also mentioned that we support SMB multi-channel. So again, on the file server, we have multiple cores. You're able to have multiple streams with those multiple cores to improve the network performance. So the file server is able to distribute your data to those clients much faster. So you're not alone if you have a lot of data on-prem or somewhere else, that you need to go ahead and migrate over to Amazon FSx for Windows File Server. So this is one architecture you could deploy in order to get that over. So again, you would have a VPN connection or a direct connect. You would spin up an instance or instances within a VPC, within an AWS. You would run an application, say Robocopy, which allows you to have multiple threads running to copy data from on-prem over to your Windows FSx, or your FSx for Windows File Server here in the cloud. So let's actually go ahead and take a look at what this looks like in real life. So I have this environment already set up. So I have 2 namespace servers. I have 3 clients, and I have 3 file systems. The file systems are the same size as the one I created earlier in the demo. And what I want to do is I want to read and write to these 3 file systems to see how much throughput I'm able to achieve. So again, these were all created using throughput capacity of 128 megabytes a second. So I have my 3 instances over here. Oh, of course. We'll go ahead and relaunch those. Somehow they got closed out, but that's OK. All right, so we have instance 1, instance 2, and instance 3. All of them have the 3 file systems mounted to it. So what we're going to do is I have a little script here where we'll run file against the file systems, and we'll see how it's performing. So on this one, we're going to go ahead and run the first script. On the second one, we're going to be hitting another one. We don't want that to get that big. And then the third will be this one. All right, so let's go ahead and kick these off. As we can see, let me shrink this down. This got a little big. You can see we're achieving high levels of throughput all the way up to 3.64 gigabits per second on all these file systems. These file systems, again, have a throughput capacity of 128 megabytes per second. So getting around 3.64 megabits per second, or gigabits per second, we're achieving close to 450 megabytes per second per file system. Again, this is under a single namespace. So as your application is writing to this namespace, and because our data could be sharded across multiple file systems based on how your data is stored or how it's separated, you're able to spread your workload across all 3 file systems, achieving much higher levels of performance and throughput, even higher than what you provisioned when you created the file system. We just finished the test, so we're doing some reads and writes against this file system. So we just launched Tuesday. We're very excited about the reception that we've received so far this week. We've had a lot of excitement around creating these file systems and what this new service can do for you. We do have introductory videos out there, blog posts, white papers, reference architectures, documentation. The user guide has a great amount of information. We have the scripts that I use today to test the performance, to set up namespaces, and to set up DFS replication. We also have a solution out there that allows you to set up a more frequent user-initiated backup on a more frequent schedule. Say you want to run it every hour. You can go ahead and deploy that solution, and you can set that up very quickly within your account. With that said, we did launch with a number of partners. So some of our partners helped us sort of test out this service during beta. So we'd like to recognize them for the hard work, and them as well as us, we're very excited to make this available to you. We do recommend that you complete your survey on the mobile app. And we have time now for some Q&A. So if you do have a question, we do have 2 mics in the aisles. Please go ahead and line up behind those mics so everyone can hear your question. First over here.
You mentioned that there was a possibility of populating and syncing back to a data lake. Can you elaborate on that at the beginning of the session?
Yeah, sure. So we launched 2 file systems as part of FSx this week. I was referring to FSx for Lustre, which is a different file system. It's a file system that's optimized for things like HPC and machine learning. And that's the one where you can integrate directly with a data lake. And so you can move your data from the data lake to the file system, process it, move it back. So happy to talk about it more afterwards if you want to stick around.
Over here.
Yeah, sorry. I wondered about differentiating NTFS permissions and share permissions for layered permissions within the Windows file system. Okay. Do you support this?
Sorry, can you repeat the question?
In our Windows file servers, we commonly apply a standard set of NTFS permissions that are different than share permissions to restrict specific groups from certain files within a share. Is this possible?
Yes, you can certainly do that with Amazon FSx as well. So you get to set your NTFS access controls. You can also set share-level access permissions because you manage your Windows file shares exactly as you would today,
just like
using, for example, the shared folders GUI that Windows provides.
All right, thanks.
Great. Back over here.
Yeah, actually, a couple questions. Solutions for antivirus, and then can you modify size and throughput post-creation?
So go ahead.
So I'll answer the question around can you modify your throughput, size and throughput. So the size of the file system is immutable. So once you create your file system, you're unable to change that. Now, if you do need to have more data, there's a couple of alternatives. One, create another file system, put it under the same namespace. Now your namespace is able to have more space. You could also set up another file system and set up DFS replication, that file system being larger, the new size that you wanted. Once all the data has been replicated over to the other file server, then you can go ahead and shut down the smaller file server, and then you have now a larger one. So today, that would be the mechanism that you would use to increase the storage capacity of your file system. In terms of throughput capacity, one way you can do it is you can't change it on a live file system, but if you make a backup and then restore that backup, you can change the throughput capacity of the file system that you're creating based on the backup.
And AV?
So regarding antivirus, are you asking, do we provide kind of a native antivirus capability? Is that the question?
Right, or are there ways to plug it into existing commercial?
Yeah, got it. So for the native one, we don't support that. We don't provide that. It is, at the end of the day, a file system that can be mounted from a server. So you can be running the antivirus software on a server that has the file system mapped, and you can run your antivirus just like you would run it against a normal file system.
Okay, thank you.
Let's go back over here.
Do you have any plans to make it easier to integrate directly with a Windows domain without having to establish a trust?
So tell me about kind of the scenario that you're thinking about, or you're asking for direct. It's not something we support now, but we'd love to hear the feedback. We've heard it from a few customers, so we'll take a look at that, but thanks.
Thank you.
Are you specifically talking about AD connector? Okay, okay, thank you. Over here.
Yeah, so in a hybrid environment with an on-premise DNS, are there lifecycle events or something that I can hook into to make sure that the on-premise DNS is updated with those ENI references?
Okay. Prash, you want to take that?
So we don't support on-prem access to the file system network interface directly today because we don't support Direct Connect or VPN access to that network interface. That is something that we are hearing a lot of feedback from customers about, and we are working on it.
Is there a bridging solution you can think of?
Yes, so you can certainly have EC2 instances that are within your VPC that are mapping your file system and that are able to give access to your file data to your on-prem clients.
Okay.
Yeah, so if you go back, we had an architecture diagram around that. So in this example, you can have EC2 instances within your VPC. Over a Direct Connect or VPN connection, if they can mount your source data on-prem, then they would also be able to connect to the FSx for Windows file shares as well. Over here.
My question is regarding recovery. Once the snapshot has been taken, is that going to be as easy as simply going to the previous version of that file system? Is that going to be presented through that, or what's the actual process to recover a file that some user has deleted?
Yeah, so in this case, this is actually a separate backup that's stored durably in Amazon S3. So the way you would do this is you would actually restore the backup onto a new file system and access your files and folders that way.
Over here.
Is there any support for audit level logging, like I would be able to do on a Windows server, the native volume? Determine what security principal accessed, read, read or wrote.
Okay.
Yeah, so we actually don't support the auditing control directly today, and that is also something that we are continuing to hear feedback from customers about, and we'd love to hear from you. Because there's a variety of ways you can actually do that, so we're trying to find the right way to give you that experience.
Okay.
Yeah.
Because in like CloudWatch, CloudTrail, I would just see basically the file system manipulation, right? The administrative.
Exactly.
version.
That's right. Yeah, that's what we provide today. And as I mentioned, there's a variety of ways we can actually integrate with CloudTrail. We can allow you to look at the audit logs yourself. So that's why we are trying to figure out what the optimal customer experience is, and we'd love to engage with you on that.
Sounds good. Thanks.
Great. Over here.
Aloha. Just very cool stuff. First question is, how long do you guys foresee this to become on GovCloud? Because that's where we work at right now. And second one is, do you have any use cases with working with SQL Server database files?
Okay, so I'll take the GovCloud one then. As I mentioned, we're in four public regions today. We know it's super important to be in every region, including GovCloud. So it's a high priority for us. I can't share specific timing, but we're going to move fast to get everywhere.
So the second question was about SQL Server use cases. So there's a variety of use cases there. We definitely support a lot of them. So there's storing your SQL Server backups, for example, on the file system. There's using the file server file shares as witnesses for SQL Server clusters. We support that as well. There's also another set of use cases around storing the SQL Server logs. We support that as well. But regarding the storage of the actual SQL Server database, the actual data itself, it really depends on your workload needs. So if you can actually store your database files without the need for a particular feature called SMB continuous availability, you can do that today. But that feature is something that we don't support today, and we will be working on it in the future. Yeah.
Good. Over here.
Just real quick, I have two things. So just to clarify, native previous versions that you typically get with a native Windows file server, those are not available in the solution.
So you're talking about the shadow copies feature,
Yes,
or the
exactly.
previous versions feature within Windows. That's not something that we
That
support
is not,
today.
okay.
Yeah.
And then I was just kind of expanding upon the need for the managed Active Directory. I think for us, one of the concerns is having the ability to directly join it to our Active Directory domain so that we don't have to incur the expense of running a managed directory for a very small function inside of AWS.
Yeah, understood. So good feedback. The managed AD service launched, I think it might have been a few months ago at this point, but a smaller version of managed AD that's significantly less cost. So that's something to take a look at.
Yep.
But I understand the feedback.
Perfect.
It's
Thank you.
helpful feedback. Thanks.
Great.
Apparently, we're out of time.
All right.
Okay, if you have further questions, please feel free to just come up afterwards. Thanks.
Thank you.